Hello everyone. Today we are going to discuss the problem beautiful towers. For first and second both, it is the solution for both. So first of all, read the problem statement. You are given zero index array max heights of an integer, and your task is to build n towers in the coordinate line, and the ith tower is built at coordinate I, and its height is height I. And a configuration of towers is beautiful if the following condition holds. The height of the tower I is greater than 1 and less than max height. And height is a mountain array. And array heights is mountain if there exists the condition that such that for every j which is less than or equals to I, having heights j minus 1 is less than equals to height j, and for I to n minus 1, its height of k plus 1 is less than height of k. We have to return the maximum possible sum of heights of the beautiful configuration tower. So let's understand the problem first. So basically, I have given an example here. I have taken an example. We having heights, and we have to tell whether this is the what is the maximum possible sum of the mountain. So mountain is like in general term, it's a peak, and both the values are less than or equals to the peak value, right? So we have to just generate. We have to pick a I, and we have to do the same. So if I pick this value as I, so the left is less than or equals to that value, and all the right are also less than or equals to 3. And they having also we having given this max height array, so it denotes the maximum height the ith tower can achieve. So if it is 1, then I take the minimum of the this height and the maximum height of that particular index. So for this index, the minimum height should be 1. For this, it should be 3 because it should be less than 3 because I am taking 3 as the height. So I have to reduce the maximum height of this tower to 3. So I can take and make it a beautiful tower. So I just the brute force approach is like I can just try out for all. I pick choose I, and check all the elements in the left and right of that particular I, in which follow the conditions that all the elements are less than this, and they follow a trend like the left elements are not it less than equal to the I, and also the right elements are following this condition that given element is always greater than equal to the right element. So we have to check out for every I and take the maximum moment. So it takes order of n square, which will easily pass your first the beautiful towers type first. But for beautiful tower second, the constraints are high. So you have to build a uh, optimized solution for that. So let's move on to the optimized solution. So first of all, what do you think? If I pick any element I as I, so what are the cases? Like if in this example, if I pick 5 as my five as the peak, means the peak of the mountain. So what are the choices we have? So we have to take we have to take the smaller value, which is so we check what is smaller than this value. So 3 is smaller than this. So now for 3, 3 this is 4, but if we consider this 5 as a tower, we have to reduce this value either 3 or less than 3, because there is a value present in the left of this which is 3. So for that I just reduce this to 3, and for this index the maximum value should be 1, and it can From 1 to 3 because the maximum ID is up to 3. So we have to take the minimum because its maximum ID is 1. So 1 is there and also 1 is there. So what this sums up? 5 plus 3 plus 3 plus 1 plus 1. So it sums up to 13. Right? So basically what we are going to do, we just pick an index and check the next smaller. What is the next smaller value from that index? And we pick a index. There may be possibility that we have to check for the previous smaller as well. So here I write the both the next smaller and previous smaller of this array. And let me just diagram for you. Will it diagram? So, yeah. So the next smaller of 5 is 1. I am just writing the indices of those values here. So the first next smaller of 5 is 3. So its index is 1. So I write 1. And for 3 the next smaller is 1. So its index is 3. So its index is 3. So I just write 3 here. And for 4 as well, 1 is the next smaller. So I write the index of that. And for one, nothing is smaller than 1 in the right of 1. So I write the nth index here. So I write the nth index. So it's 5, and for this one also it's 5. So I'm done with the next smaller value. Now I have to calculate the previous smaller for every value. So for 5, is there any element with that? No. So I have to write -1. And for 3, is there any element which is smaller than 3 in the left? No. So I write -1. And for 4 as well, we know 3 is smaller than 4. So I write 1 here, the index of 3. So it's 1. So now for 1, is any element smaller than 1? No. So I write -1. For 5 also, there is no element which is smaller than 1. So I write just -1. So now I am done with the next previous and next smaller. What we are going to do, we take an I. So we are taking an I. So here then this is I take a specific I and check what is the next smaller. So because I know from this to this all the values should be greater than this index. So I can just write the what is whatever in this index, the value of that. So it's num of this index into the length of that particular segment which is greater than, because if this is the next smaller than this index, I know all the values are in between are absolutely greater than or equal to that value. So I can make, if I choose this index as my peak, so I can make all the elements from this to the next smaller uh, same as that value only, right? Then for this index I check for the same, so next smaller, and I make all the value to do whatever the index in this. So and if I choose, like, if I choose any element in the middle or any index as my uh, is my peak. So what I have to do, I just check for the next smaller, and then for its next smaller, and here I recursively I check for its next previous smaller and previous smaller, and compute both, right? Compute both recursively, and I am done with this index, right? I have calculated its right next smaller values and previous smaller values as well. So I recursively calculate all. And when I done with this index, I having some answer in this. Like I for the right half, I know what is the maximum value it can take, what is the maximum value it can achieve, and for the left half, I also know what the answer. So this index is computed on both, means I take this as right also, and I take this as left also. So this index is like I have take 2 times. So I have to just reduce the left right minus that index, because I am taking that specific index twice, right? So I call out recursively for every index. If I am so basically what I'm just doing, if these are the array elements, what I'm doing, I pick any element as my peak, and what I do, I just go to its next, next smaller, and then compute the answer for this segment. And from that, I go to the next segment, which is next smaller for that index. So I just compute the answer for that. So at last, I am done with the right half. And similarly, I do for the left. Left is smaller and compute the answer. And for from that index, I go left and compute the answer. So now I am done with the left segment answer, the answer for the left segment, right? And I am taking this specific value in both left and right. So finally, I have to reduce. I have to what is the final answer? Maximum final answer for that particular index. That's left plus right minus x. Why minus x? Because I am taking this index in both left and right segments. So that's why I have to reduce this finally. So I iterate over the array and check for every elements left and right and compute the answer. And I try out recursively for those segments. And I if I like I calculate for a particular index what should be its left and what should be its right. Right. So if I calculated this for any index, I store it in a array. And if in the future I for the same segment, I return just the stored value, right? I don't have to recursively calculate for that particular index again. So I'm just using dynamic programming here. So let's see the solution for better understanding. So first of all, I calculate the next is smaller and previous is smaller for the given array, right? And here I how I calculate. You can see the how to calculate previous is smaller and next is smaller. So I just take the values in stack and check whether the particular value is greater than my given value. If it is, I just pop out till the value is less than the value of the top of the stack. So I just put that value and calculate the previous smaller and next smaller. You can see these how to calculate next smaller and previous smaller separately. So I done with next and previous smaller. And now I just create prefix and suffix, which is storing a particular index which I have done for that particular if I have done it for a particular index. So what I'm doing here, I'm just taking sum at 0 and checking my whether my temp is equal to -1 or not, because I am calculating here the left segment. And if my prefix is already like I have calculated this earlier, so I just summed up this with my value sum and break. And if not, then I can compute this for that index. How I compute? I take the length of the segment which I am using into the value of that value, and then sum them. And then I update my temp as the previous of temp, because here what I am doing, uh, if I am at any index and I compute for its previous, so I am done with the segment and I sum this. So I'm done with this. So now I have to compute for this also, because I have to compute this segment is left out. So I have to compute for this. So I make a recursive call to do this compute to calculate answer for that particular index also. So I am doing keep doing this till I found that my index is -1. If I found my index is -1, I stop at that point. So I stop whenever my temp is -2. Then I store the prefix in the sum as my in prefix array. Then I again initialize my sum to 0, and here I compute the right segment. I do the same thing like in the left segment. I calculate a similar way to the right segment, and finally I just um, take the suffix and store the right segment also in the sub. And if I am at a particular index, what can I do? I just add the prefix plus suffix minus that particular index. Means I can here I will show you like if I am at If I'm at a particular index, I compute the left and right. And if I am taking this particular value in both of the segments, so I have to subtract this from the summation of both, right? So I do the same. I subtract this and finally I calculate the result and return it. So this is it for this column. Your solution is also passing default hour first, right? So I hope you understand this problem. And for more such videos, like and subscribe to our channel. Thank you.